Alright, welcome to my next trig video. In this video I'm going to show you how to calculate trig function values of angles when given these triangles. Right? These triangles, notice, are not in the unit circle. They're just kind of off on their own. They're right triangles, so we can continue to use our SOHCAHTOA. And in this case I'm asked for the sine of theta. So we'll remember that the sine of an angle is opposite over hypotenuse. So in this case, the opposite side is not immediately known. That's the opposite side. The hypotenuse is 15, so we're going to go the sine of theta is equal to some unknown side opposite divided by 15. And we just need to find that opposite side. So let's go Pythagorean theorem, 12 squared plus, let's call it b squared, equals 15 squared. So 144 plus b squared equals 225. Subtract. (225) minus 144, so that's 1. This is 81, which means b is the square root of that, or 9. Alright, so our opposite side is 9. 9 here and 9 here. And we'll simplify that if we can. Right, they're both divisible by 3, so we'll take them down to 3 over 5. And that's our answer. Alright, this is a Pythagorean triple. Right, if you cut all these down by 3, it's a 3, 4, and a 5. 3, 4, 5. Moving on. Cosine of theta. Alright, remember, cosine of an angle is the adjacent, the next two, divided by hypotenuse. So in this case, next two is going to be 7. So cosine of theta is 7 over the hypotenuse. I don't really know right now, so let's figure that out using Pythagorean theorem. 7 squared plus 24 squared equals h squared. So this is, let's see, 49 plus 24 squared, I think, is 496, 476, I can't remember, 576, goodness, equals h squared. And we'll add those together, 576 and 49. That's 5, that's 8, and 4 is 2, so it's 625. And you take the square root of that and you get 25. So the hypotenuse is 25 units. So 7 over 25 is the answer. There you go. And if you wanted to actually figure out that theta measure, you would take the inverse cosine, or the arc cosine, of that right there. So if you press second cosine, 7 over 25, you get about 73.7 degrees. Alright, but for this problem, all it's asking you is, just to find the ratio. So 7 over 25 would be fine there. Let's do some tangent. Remember, tangent of an angle is opposite over adjacent. So in this case, opposite is 9. Adjacent, we don't know. I'll call it lowercase a. So we want to go tangent of the angle is equal to 9 over a. And again, we're just going to do Pythagorean theorem. 9 squared plus a squared equals 15 squared. And this one looks familiar. 81 plus a squared equals 225. So a squared is equal to 225 minus 81. So that's 4. We'll carry this over, 144. Alright, so a is 12. So it's 9 divided by 12. 9 over 12, 3 over 4. So tangent of theta is 3/4. And again, if you wanted to find the actual theta measure, you would just take the arc tangent, or the inverse tangent, of 3 over 4. Cosecant's next. All right, remember, we know that sine is opposite over hypotenuse, and we also know that cosecant is 1 over sine. So cosecant is not opposite over hypotenuse, but it's hypotenuse over opposite. And we'll use that idea here as we solve this one. So hypotenuse, I have no idea. The opposite is 3 radical 5. So if I go cosecant of theta, I get 3 radical 5 over whatever h is. So let's find h. 2 squared plus 3 root 5 squared equals h squared. So this is 4 plus, so this is 3 root 5 times 3 root 5. And all you do here is you just multiply 3 times 3 to get 9. Radical 5 times radical 5 is just 5, so this is 45. So 4 plus 45. 45 and 4 is 49. Square root of 49 is 7. So our hypotenuse here is 7. Alright, so this answer is 3 radical 5 over 7. Hypotenuse over opposite. And you can't simplify that anymore, so you're done. Alright, 2 more here. Remember, cosine is adjacent over hypotenuse. Secant is 1 over cosine, it's the reciprocal function. So secant's going to be h over a. Just flip cosine over. So here we go. Hypotenuse is 15. So the secant of theta is 15 over the adjacent. I don't know what the adjacent is, so I'll figure it out. 12 squared plus the adjacent squared equals 15 squared. And again, this one looks familiar. A squared is equal to 225 minus 144. I get 81. And a is 9. So it's 15 over 9. And we'll simplify that. Divide both by 3. I get 5 over 3. There you go. Last one, cotangent. Remember, our tangent is opposite over adjacent, and we know that the cotangent is 1 over tangent, which means the cotangent is a over o. So this one has an adjacent that we don't know and an opposite 3. So cotangent of theta is a over 3, and we just need to find a. Let's figure that out. So we'll go a squared plus 3 squared equals 5 squared. A squared plus 9 equals 25. A squared equals 16. A is 4. So a is 4 in this case. So our final answer is just 4 over 3. The cotangent of theta is 4 over 3. Now, for all of these, you could have easily just been asked to find sine, cosine, tangent, cosecant, secant, and cotangent of every single angle every time. All right, you'll see that a lot. Problems will be worded that way where you have to find all 6 for a particular angle. And if that's the case, it's no problem. You just run through all of the ratios and you're good to go. So there you go. Pretty quick video on how to work with these right triangles, finding sine, cosine, tangent, and all the reciprocals. So thanks for watching.